All right, here we are. Let me do some check on my Excel in this computer. And let's see where we are. This Excel, it seems like it's missing few things here and there. Let's see. Under the data, but under formula, yep, I don't see developer. I do see data, but I don't see the solver. So there's few things here and there that this Excel need in order to use it for the course 4006. And to do that, let's go right here to File, Options, and let's find out. How about add-ins? Okay. In add-in, I see a few things here missing. Let's see. Excel add-in. Yep, it's missing. These two are missing. I need those two just to get my Excel up to, to where I want it. So let's add this one. Let's say go. And now, analysis toolpack. Analysis toolpack, the Visual Basic, yeah. No, and the solver. And the solver. Euro currency tool, I don't need that. I'm not planning to go to Euro by the time being. So more than enough. Those are the three things that I really need. The analysis toolpack, the analysis toolpack with Visual Basic, and the solver adding. When I hit the OK, let's see how my Excel behave. And I'm kind of timing how long it takes to do the installation of those add-ins. And again, this is just to get Excel up to speed with what we need in our course. Just in case that you have Excel, but you don't have these add-ins, they are important. So I'm adding them, and let's see what happens. I'm using 2016, the Microsoft 2016, and let's see how this looks like now. Yeah, I can see now solver is right here and data analysis. That's good. That's good. Let's see. Now, I used to 2000, I don't know, 20 maybe, the Excel that I'm currently using another computer. This is 2016. Kind of wondering. Home. Let's see. Data review view. Did I need to do something else for the developer part? I don't see the developer yet here. So let's see whether, again, let's see, options. Maybe it's here somewhere. Oh, here it is. That's it. That's all what I need. I thought for a second where the developer went. Is under custom ribbon, main tabs. You need to kind of check it, check the box. Now it seems like it will work the way it should. Okay. And so there we go, developer. All right. Took me a while to figure it out. Maybe where it was, but now it is there. So under data, I have the solver. When you're solving a system of equations, and or maybe nonlinear equation, that will work as well. How about under developer? The nice thing is that you can add functions, special functions, and let's see if that works. Okay, let's say that for now I'm gonna have a special function. Want to go to developer and insert a new function, and let's call that function. Let's go here, insert module, and function. I don't know. Let's call this function Daya. That's just a name like Dayanara. And put a name here, put an argument. What's going to be? Let's say that it's two arguments, x and y. And let's see. And let's call what we're going to do with that will be x plus y. That will do. Space between, and that's it. So if I put argument x and y, it's going to be added, and the solution will be right on this function that I'm writing there. So with that said, we can go back again here. If I press anytime here and start to work, you see this the name right here because I inserted it, and it's not permanent. I mean, when I close Excel, if you don't want it, it's gonna disappear unless you want to save it. So let's say 2 and 2. That's 4. 2 plus 2, 4. I mean 2 plus 2, 4. So because that's what the formula said that we need to do. Going back to again to my Visual Basic, if I want to do something more fancy, like for example x space square, then that will be x squared, whatever. For that, you will add the value of that you have here on the y. So let's do that. Let's see what happened. Again, we go back here, close and return, and we put here somewhere the word data, and let's put the argument. That's going to be like 2 and 2. So now 2 squared, that's 4, plus 2, that's 6. You can change again the argument, put a 10 here, and that's it. So make life easier, and anytime that you need to use the special function, it will work that way. So let's see, 5, yeah, 5 squared, that's 35 plus 10. That's 25 plus 10, that's 35. Perfect. So that's how easy it is just to introduce a function. Anything else? I mean, you can add more argument if that's the case, like a 3-argument function like x, y, and z. Let's say that I have another argument here, and I need to add another value here, plus z. X squared, and that's my function. If that's the case, what you have to do then, when you go back here and add the 3rd argument, let's say plus 1, and that's 36. So those are the 3 arguments that you need, and that's kind of nice, makes life easier. The other thing that you could certainly do, like for example, let's say that this is my x, and this is my y, and this is my z. You can pull those values from here pretty much directly, and you don't have to mess a lot with it. Like for example, like let's do this. Let's put here 2. Well, actually 5. I think that was 10, and this was 1. And what I could do is definitely I can pull the value from here, but if I want to change the name of that value there, what I certainly could do, let's see, where would that went? Define name. See, under formula define name, you define a name. Look at it. It knows that somehow this number here has to do something with this x. You can call it x, and now the next number define, you can call it y, and the last number, go to define, and you can call it c. And the nice thing about that is that you can, change this word here, like x, y, sorry, so y and c, and the function will take care of that. So anytime you change a number here, this will be updated. Let's see, 4, you see, 3, it knows. And that's one thing that you certainly can do. Like, for example, when you are taking those derivative, f of x plus h minus f of x divided by h, we can certainly do that. And let's do a quick example here, and let's see how this looks like. Let's finish this. Let's finish this with some, kind of an application. How can we use that developer part and all that? Let's see. Let's put a function here, f of x, and let's say that f of x is something simple, like x to the cube plus 2x plus 5. All right, that's it. That's x to the cube. If we want to do this like the analytical solution of that function, so we can say f prime of x. Actually, I'm writing because, so they look good. Might look like this, right? So it will be a function of x. Now, one thing that I can certainly do, let's see, we can add the x somewhere here, insert, and let's say that x equal around, we want to do this derivation around 2. And one thing that you could do when you are there in formula, let's see, you can define a name, and it knows workbook. Let's see what else I have here. Yeah, let's make it only for sheet 1. And x is gonna be like, this is important. If you pull like workbook, it's gonna be around everything, and that definition maybe is true only for sheet 1. So let's say sheet 1. What I'm saying is, right now I'm calling this number 2 my x. Just say okay. And now the nice thing is that I can do the derivative right here without calling that number, only by calling x. Like, for example, 3 times x squared plus 2, and that's it. Then you have your analytical solution, and that's 14, and that comes from here. So you have the derivative, very simple, by using that definition. Now, let's do a little bit more fancy stuff now. Let's say that I want to calculate the derivative, but numerically. Like, for example, f of x, f prime of x, by definition of a derivative, will be something like f. Let me not use the equal, just f, because it's just the formula that I want to write here, minus f of x, and put a parenthesis. This is parenthesis here, and there's a parenthesis here, and all that divided by h. Right, that's it. So that's the definition of the first derivative of a function. And so the idea is that I want to tackle this, but here somewhere. But instead of writing everything again, one thing that you could do is define a function like this, so that you do x plus h. Now, I have x here. How about the h? Well, you can put the h somewhere here and put the number there. So it's going to be 0.001. And And let's call that number there define. Again, not a workbook within our sheet 1. That's going to be age. She knows a little bit, Excel knows that you want to call this age because this is what is nearby. So definitely, just say OK. So now I have X well defined, the age value well defined. And the only thing that I need to do is get this function within Excel. And define that function. We go to developer, we go to visual, and we go to sheet 1. We insert a module, and we write the module function. And you can pick any number, any name. Let's see. Let's call this. You can call it anyway. Let's call HTD or HT. Let's call it no. Actually, let's call it first D, first derivative, and that will be the only thing that I need to pass is the value of x and first derivative will be then the function that I have. I think that it was x space to the cube space plus, I believe, was 2 times x let's see, plus 5 maybe. uh, First t, let's go back here and I fix it. So the function, yeah, it x to the cube 2x plus 5. So we go back here and we check 3x to the 3, 2x plus 5. Excellent. So my function is called first d, and we go back here. And like, for example, if I want to do f prime of x, is as simple as calling first, it's right there, first d. Now, first d is doing the I call it that with that name. It doesn't matter how you call it. But the idea is the first d, the first part here is fx plus h. So you need x plus h. See, it is right there as part of. And the next part will be minus first d, and that here will be x. And you need to put a parenthesis because that the differences between this part and this part will be divided by h. So you are actually using the formula the way it was set in math, right? So you got the first derivative. The analytical solution was 14. The numerical solution was 14.006. Pretty good, pretty good. Uh, Again, I can make the function very complicated. And it would not matter because when you do this, you get the actual value at whatever evaluation, whatever value you need to evaluate the derivative. Like, for example, if I need to get this derivative evaluated at 5, you just put the number 5, automatically you can see that the number are pretty much very close. Then analytical solution versus the numerical solution. Now, one thing that you have to be careful when you get into Visual Basic here, sometimes I have some trouble if this function has already been defined by something else or I used it before. It gets kind of crazy. For example, I tend to use a lot let's see, F1, and let me see if I get the same error sometime. F, X01. Uh-huh. And let's see if I go back here and let's see if it fails to do that. It still remember. Let's see. Yeah, now okay, great. It couldn't find the first D. It's gone. So it doesn't know that function. Now let's change the word first D for whatever is available there, which should be fx1. And so this one here, fx1. See, somehow fx1 get you in trouble. For some reason, I think that I have really defined fx1 somewhere here, and it fails to get me the proper reference. I need to change the name, the number. It may be I have used it before, and I think that I inserted within the Excel sub, and it get confused. I have to change the name. For example, if I change the name, let's see, go back here to Visual, and instead of calling fx1, let's call it fx, I don't know, ftest, ftest, ftest. I hope that that's not an illegal name, ftest. Let's see. Now go back here, and let's see if I can put ftest show up there, right there. Oh, I got here one is called, ooh, careful. I don't know. Maybe it will not work because, yeah, I thought, yeah. Let me stop here and let me go back here and change the name. Let's call this FT. Let's see if FT will create a problem. FT look good. With okay, let's see. FT, yeah. How about this one? FT. Yep, now it works. So I have to be careful with the name. It get kind of weird. But now it works. So got the first derivative, and you can change this number, playing around with it. At 110, you can still get very good results for the first derivative using numerical differentiation. You can get this more complicated. Like, for example, you need a second derivative. You could use the definition from Chapra. And let me do that for 1 second. So, for example, let's get some definition for first, second, and third derivative, maybe fourth derivative. And that might come right directly from, I mean, this is the 6th edition on this book, Numerical Method for Engineer. There's a 7th edition as well. And let me go to the page here. That's going to be, I don't know, 673 maybe on this edition. Yeah, that will do right there. And so let's get a little bit larger and larger. All right. So what I have there is first derivative, forward derivative type. You want more accuracy, you can use this equation here. It's a little bit more complicated. How about the second derivative? You can use this, any of these two. For the third derivative, you can use this or this one. Actually, depending on what you're doing, eventually, I think I mean, definitely we need this third derivative. And let's use the complicated one. This one down here. That's of the order of h squared. Very accurate if the value of h is small. So with that said, let's get a third derivative and let's compare that with the analytical result and let's see what happens. So we copy this. Let's see, shift, print screen, and we move now to paint to get what I really want. And let's do a paste there. Only copy the third derivative, both of them. There's a fourth derivative in case you want that, but not at this point. more than enough to use the third derivative, which is this is the definition. Copy that down and then move to Excel. And we did this. So let's put this somewhere here. And here's the question. I know that my function is called ft. So if I go to ft, I need something that can hold for the third derivative. The way it is right now, a third derivative will be, I got the first one here, the second will be 6x, and let's do it to a higher level. Instead of being x to the 3, let's put x to the 4. Let's see. X to the 4. Now, let's go to my Visual Basic and change that x to the 4. And accept that. Close and return. Now, do the derivation here. That will be 4 here. I'm changing because I changed the 4x to the 3. And 2 plus 2. And that's it. Let's see. 866, 866. Not bad for the first derivative. Now, I'm doing analytically, so let's insert here. Insert. What would be the second derivative? Well, the second derivative will be like that one. Let me copy this. Copy. And put it down here somewhere. Oops, undo. And so equal. Now, that's the first derivative. So now I need, the second will be done, the 3 by 4. That's going to be 12 times x to the 2, and this 2 is gone. So now that's the second derivative, f of x, analytical result. The third derivative, insert, oops, undo. Insert the third f, third derivative of x. Again, analytical solution. We can copy this, copy, and paste it here. But then that would be 2, 12, that's 24, and x only. That's 144. So this is the function, the original function. The first derivative was this, 4x to the cube plus 2. And then the second derivative was that 3 times 4, that's 12. 12 x squared, right there. 12x squared, and then the next derivative will be 24 x. So the third derivative is very straightforward. I'm presenting a simple case because then you can build this function here. Could be very messy, but the solution will be the same. So if I want only the third derivative, I want to put this one here, f, third derivative, but it's going to be, and this is around 6, right? I'm doing the derivation around this number, 6. So if I want to do down here, I'm going to use this is the complicated one. The only thing that I need to do is, for example, let's start easy here, equal 3 times, now the function, I call it ft, if you remember. If you don't remember, let's go back here. It's called ft, my new function. All right. So it's going to be minus 3 times ft of what? And here it says x, so it's going to be x plus 4 times h. See, close the parenthesis, plus 14. And this is the advantage of doing this like this. Otherwise, it's going to be very complicated, very messy. ft time, I'm using this part here. And that's, it says ft of what? Of x plus 3 times h, close the parenthesis. And now minus 24 times ft of what? And this will be x plus 2h. Oops, I haven't finished. Where it went? Here. X plus 2 times h, close the parenthesis. So I got the 3ft minus 20, the 14fx3h minus the 14fx2h plus 18 times ft of x plus h minus 5 time f of x. That's it, of ft of x. Ft, remember that function is called, it's called ft. That's my function. And but that function of what? Of x. Now, easy here. There's a parenthesis right in front. There's one at the end. And all that need to be divided by, open a parenthesis, 2 times h to the q, close parenthesis. All right, so this is this here. Now, let's double check. 3 times ft of x plus 4h, that's the 4 here, that's what it means. Plus 14 times f of x plus 3h minus 14 ft x plus 2h plus 18 minus 5 times f of t of x, and there's a parenthesis here which go with this one, everything divided between 2 and h to the q. Well, look good, except that I failed to put the equal in front. All right, let's put the equal. Now it's pulling the numbers right from here, you can see, and that's the number. 144.0075, 144, the third derivative. How about that, huh? Perfect, right at the money. So again, you can have a very weird function that you need to integrate, but if for somehow you need the third derivative because you are using Simpson, either 1/3 or composite, you will need the third derivative, period. And if the function that you're integrating is complicated, to get those derivatives, maybe they're harder to obtain analytically. But if you can use like this numerical method, it's going to be very straightforward. All right, I think that I covered more than enough within this video. Again, you can complicate the function, do a very weird function here. You can paste anything that you want now. You just need to go and redefine ft, and everything will be done. If you need to calculate this derivative at another value, like 3, for example, hit the number 3, 72, 72. So, like for example, what this value means is the limits of your, for example, your integration. You want to integrate this function between 3 and 6. So this will be the value of my third derivative evaluated at value of 3. And then how about 6? Then you put the 6 here, and you get the value done. And again, you are confirming that this is correct based on that this is very simple to get the first, second, and third derivative. Very straightforward to do. Wow, more than enough. As I always said, be safe, whatever be your final destination. Thank you. Bye.